rational expressions. We'll start with products, so let's find each product. Example 1. If I had 3x divided by 16x squared times 8x squared divided by 3, and I want to simplify. Recall, we can use cancellation on this problem. I can cancel out these 3's, I can cancel out these x squares, and 8 goes into 16 too. And what is left will be my answer. In my numerator, I have an x left. In my denominator, I have a 2. Example 2. If I had x plus 3 divided by x times 5 divided by x squared plus 7x plus 12. Well, this denominator needs to be factored, so that becomes x plus 3 over x times 5 over. I'm going to factor this. I need two numbers I can multiply, get 12, combine and get 7. So those numbers would be a positive 3 and a positive 4. Now I cancel out anything that they have in common. They have the binomial x plus 3 in common. What is left in my numerator, I have a 5. In my denominator, I have x times the expression x plus 4. You may leave it like that, or you may multiply it out. Preference, just leave it as it is. Example 3. If I had y squared minus 3y minus 4 divided by y plus 5, and I'm going to multiply it by y plus 5 over y squared minus 4y. Well, I'll go on and cancel out the y plus 5's. Factor this. I need two numbers I can multiply and get a negative 4, combine and get a negative 3. So that would be a y minus 4 times y plus 1. And that's going to be over, the GCF here is y, so that'll be y times y minus 4. Cancel out what they have that's alike. My simplified answer is y plus 1 divided by y. Now let's take a look at division. Let's find each quotient. Example 4. 15y squared divided by 4x, and that is divided by 5y over 8x cubed. Remember, when you divide by a fraction, you multiply by its reciprocal. So I need to rewrite this problem as a multiplication problem. That's times the reciprocal of this would be 8x cubed over 5y. Now let's do some simplifying. I can use some cancellation. 5 goes into 15 3 times. 4 goes into 8 2 times. Now I have an x cubed divided by x squared, x to the first. When I subtract the exponents, I get an x to the second. Here I have a y squared divided by y to the first. When I subtract the exponents, I'll get y to the first. So in my numerator, I have 3 times 2, which is 6. I have y times x squared, which is x squared y. That is division. Problem number 5. If I had 4x minus 8 divided by 2x minus 6, and we're going to divide that by 2x minus 4 over x minus 4. We're going to do some factoring. 4x and 8 have a GCF of 4, so I'll factor out a 4. So I'll have 4 times the expression x minus 2. 2x and 6 have a GCF of 2, so I'll factor out a 2 and get 2 times the expression x minus 3. Then we're going to multiply by the reciprocal of this, so that becomes times that x minus 4 goes to my numerator. As I factor this, they have a 2 in common, so it's 2 times the expression x minus 2. Now let's see if there's anything at all that we can cancel. I can cancel out the x minus 2's. Well, 2 times 2 is 4, and I have a 4 here, so that means I can cancel out the 2's and the 4. I am left with my answer of, in my numerator, I have x minus 4. In my denominator, I have x minus 3. Example 6. M squared minus 4 over 5m divided by m minus 2 over p plus n. This is called the difference of two squares. Its factored form is the binomial m minus 2 times the binomial m plus 2. That's over 5m. Multiply by the reciprocal of this, I get p plus n over m minus 2. Cancel out what they have in common, n all over 5m. Example 7. If I had q squared plus 3q plus 2 over 12 divided by q plus 1 over q squared plus 4. This trinomial needs to be factored. Two numbers I can multiply get 2, combine and get 3, so I'll have a q plus 1 times a q plus 2. Multiply by the reciprocal. Remember, you cannot factor the sum of two squares, so that it remains as q squared plus 4 over q plus 1. Cancel out whatever they have in common. So my answer is the binomial q plus 2 times the binomial q squared plus 4 all over 12. One last example. Example 8. If I had 6x minus 12 over x plus 5, and that is divided by the binomial 12x plus 18. I need to factor this numerator. 6 and 12 have a GCF of 6, so that's 6 times the expression x minus 2. I need to multiply by the reciprocal of this, so that's going to become 1 over 12 and 18 have a GCF of 6, so I have 6 times, 6 goes into 12, 2, so I have a 2x plus 3. Now let's cancel out anything that they have alike. What they have alike is a 6. So my factored answer, my simplified answer is the binomial x minus 2 over the binomial x plus 5 times the binomial 2x plus 3.